All right, so today we are going to still be talking about the zeros of polynomial functions. We're actually talking about the fundamental theorem of algebra. So this is why algebra is even in existence, is really just to find zeros. So the basic principle of algebra is to find zeros. And so it's kind of wordy, but basically it's saying if you have a polynomial that isn't a constant, so the degree is larger than zero, then there is at least one number in the complex number system, real or imaginary, that makes it equal to zero. And then the linear factorization theorem takes it one step further. That says basically the number of linear factors matches exactly with the degree. And so it also means that a function has precisely n zeros. So the number of zeros should match the degree as long as you take into account the multiplicity. So if a zero has a multiplicity of 2, you count it twice. Or if it has a multiplicity of 3, you count it 3 times. If you do that, then the number of zeros matches exactly with the degree. And you guys, we did that on Friday, where I kept telling you you should have 4 zeros and you should have 5 zeros because it matched with the degree. Okay, then we have the rational zero test. So some people saw tests on the board and thought we were taking a test today. We're using this to help us make a list of possible rational zeros. So before, we had some like this on Friday. We would have a function maybe like this. Oh, that's fine. Let me just change this real quick. Sorry. And we found zeros by factoring by grouping. Now today we're going to have some that look like this. Can we factor that one by grouping? No. So we have to know another way to find zeros. When we can't factor a trinomial by grouping, we need another way. So what we're going to do is make this list of possible zeros. And so to make a list of possible zeros, you're going to take the factors of the constant and divide it by the factors of the leading coefficient. And that is going to give us a list of numbers to try that are possible zeros for our functions. And then once we find one or two that is a zero, then the rest of it we can just solve like either by factoring or a quadratic formula or some other way. All right, so on example 1, we are going to list the possible rational zeros. So P consists of a list of all the factors of the constant. So I'm going to call that P. What is the constant in this situation? -5. I'm sorry, -15. So the factors of -15 are going to be positive and -1, positive and -3, positive and -5, and positive and -15. Okay, and then Q is going to be the factors of the leading coefficient. And in this case, the leading coefficient is 2. Let's see, that's going to be positive and -1 and positive and -2. Okay, so what we're looking for are the possible rational zeros. And that's going to be taking all the p's and putting them over all the q's. So what should you get if you take all these p's, the blue list, and put them over 1? What's going to happen? It's the same list, yeah. So we're going to list out the p's. So when we put them over 1, we get that same list. All right. And then we're going to take them and put them all over 2. Okay. So until today, you've either been able to factor from the beginning, or you have been given a factor or been given a 0. Today, you're not going to be given anything but the function. So you are going to have to find a 0 from something in this list, at least one, maybe 2. Just, you're all on your own today. Okay, let's do one more. So for B, that's it for that one, yeah. So that's just listing the possible rational zeros. We don't know if any of these are actual zeros, because it could be irrational zeros or they could all be imaginary zeros. We don't have a list for those. All right, so for P, we're going to write the factors of 24. There's a bunch. All right, and then for Q, we're going to write the factors of the leading coefficient, which in this case is 1, so that's easy. All right, so for our possible rational zeros, we're going to put P over Q. So if we put all that green list over 1, it's just going to be that green list. I don't feel like rewriting it, so I'm just going to draw an arrow. Right, so if this function has a 0 that is a rational number, it is in that list. Now, several years ago, like before, maybe the last time I taught this with a graphing calculator was 2017, we would use the calculator to find a 0. Do you guys remember what a 0 looks like on a calculator on the graph? Crosses the x-axis, so it's an x-intercept. So we didn't have to do all this stuff. We could just get it from the calculator, but you guys can't use the graphing calculator, but it's okay. We just have one more step. All right, so what we're going to do is make a list of the possible rational zeros, because we're just going to be given the function, no extra information. Then we're going to test the numbers in the list using synthetic division to determine if they are actual zeros. So what's going to happen if it's an actual 0 when you do synthetic division? Right. Remainder of 0. Bless you. Okay. And then if it's a cubic function like B was, then you only have to find 1, and then that will leave you with a quadratic that you can solve. Like, you guys know how to solve every quadratic equation in the world. You either factor it, do the quadratic formula, or complete the square. If it's quartic like number 1 or example A was, then you're going to have to do it twice. You're going to have to find 2 zeros from the list and then solve the quadratic using whatever you got to do. All right. Now there is a shortcut to figure out if 1 is a 0, because You are just guessing. You are just looking at that list and just making a guess and then testing it to see if it works. But 1, you don't have to guess. So to check 1, all you do is you add the coefficients and the constant. If it equals 0, 1's a 0, and you just go ahead and work from there. Right? So on example 2, we're going to do all the things, starting off with listing the possible rational zeros. So that's your P's and your Q's. So anytime I notice that this leading coefficient is 1, all you really have to do is list out the factors of the constant. That's going to give you your possible rational zeros. Okay. And then we can check 1 kind of in our head. So you check 1 to see if 1, because 1 is going to be in every list, every possible list. So we would just add and subtract those coefficients. Now this time I got -12. So 1 is not a 0. So don't even worry about 1. There's no way 1 will work. So we are going to find the zeros. So kick out 1. So that still leaves 7 numbers to try. So -1, positive and -2, positive and -3, or positive and -6. And you can't just look at them and know. So we're going to see who is a good guesser. So Ashton says 6. Check it and see. So do synthetic division and see if you get a remainder of 0. Make sure you fill in 0x². Ty, what did you say? 3? All right. Check 3. If you guys think it's something else, check it. Put it in the box. Do synthetic division. If you get 0 for a remainder, let me know, and then we'll use it. Six didn't work, did it? It's okay. You're just guessing. Did 3 work, Ty?
Yeah,
3 works. It does. There's actually 3 numbers in this list that work on this one. Yep. So whatever one you want to do it. If you haven't found one yet, do 3 with me. Okay. So if you take a cubic and you do synthetic division once and get a remainder of 0, what does it take it down to? That was a lot of words, wasn't it? It takes it down to a quadratic. Now, if you use something other than 3, it's okay. Just write your quadratic. Don't change it. Go ahead and write your quadratic. And then we want to see if this will factor. If it won't factor, we'll just have to use another method. It does factor. All of yours should factor. Okay, so we're ready to write out the zeros. So if x plus 1 is a factor, what's your 0? -1. And then for x plus 2? Now, how many zeros should this one have? So where's the other one? It's the one that Ty guessed. So even if you did different than me, you should end up with the same 3 zeros. Okay, so it's not that different of what we've been doing. You just have to do some guessing at the beginning. All right, and then the last step is to write the polynomial as a product of linear factors. So it's just kind of going backwards. Okay, that's your product of linear factors. And those are your zeros. Okay, any questions on that one? Okay, so let's look at example 3. Example 3 is another one that we don't know how to factor. Like this, it won't factor by grouping. We don't have a way to factor it the way it's written, so that's okay. we can still do it. So we're going to start off with our possible rational zeros. And this leading coefficient is 1. So all we have to do are write the factors of -4. Okay. And then I'm going to check 1 in my head, or I'm going to write it down, but you can check it in your head when you're doing this on your own. All right, it doesn't work again. So 1 is not a factor or a 0. If it was, then you would put 1 in the box and do your synthetic division, but it's not. Now this time there is only one rational 0. So let's see who can find it. Who's a good guesser? Don't do 1, but -1 or 2 or -2 or 4 or -4. Alyssa already got it. She said it was 2. She's right. Now, don't get frustrated if you're doing this on your own and you don't guess right first, because sometimes it takes some time. She's right. Okay, that was a cubic. If it's a cubic, we only have to do that one time, and it takes it to a quadratic that we can solve either by factoring, completing the square, or the quadratic formula. Is this one going to factor? No. There's nothing that adds to get 2 and multiplies to get 2. That doesn't exist. So we're going to have to do something else. Would this be a good one to solve by completing the square? If you like completing the square, yes. So if this is 1 and this is even, it's a good one to do that. If you hate completing the square, you don't have to do it. You can do the quadratic formula. It's up to you. I want you to be good at both of them, actually. So if you're going to complete the square, you move over the 2. And what do we need to add? 1. Okay, so it is the square root of -1. I. All right. So we get a couple more zeros. So we get -1 plus I, -1 minus I, and then the one we got from guessing, which is 2. Now I graded your papers from Friday. I just graded that one assignment D, and a lot of people messed this up. So it's fine. Okay. So they messed up on the factors when it was imaginary like this. So be careful. So you're going to have an X in your factor, and then you're going to change both of these signs. I don't know if it was you, but so we would change the -1 to +1, and then the positive I to negative I. It was a lot of people. It was enough to make me emphasize it today. Then same thing on the next one. So X, and then you have to change both of those signs. So +1 plus I. And then nobody messed up on the ones that were integers. That was fine. X minus 2. All right. We got one more to do. This one is kind of a doozy. It's a lot because it's a quartic. So we're going to have to find 2 possible zeros that actually are zeros. And then we've got the 9 as leading coefficient. So it's a lot. But we're going to start with listing out the factors of 24, which we've already done. We'll do it again. Right, and then Q is going to be the factors of 9. And there's several of those. All right, so our possible rational zeros, we're going to take that whole dark blue list and we're going to put it over 1, which is going to give us that same list. Then we're going to take that whole dark blue list and we're going to put them over 3. So what about this positive and negative 3/3? Don't worry about it because it's 1 and 1's already in the list. All right. And the same thing, positive negative 2/3 of 2 is already in the list. So pretty much if it reduces, it's already in the list. So 12/3 should be good and 24/3 should also be there. All right, and then we'll do the same thing with 9. Put each of those over 9. If it reduces, is probably already in the list. So 3/9 is 1/3, already there. 6/9 is 2/3, which is already there. 12/9 is 4/3, and then 24/9 is 8/3. So they're already there. So this is our list. It's a lot of numbers. Now I do try to write these so you don't have to worry about the fractions. I'm not saying they're not going to be rational zeros, but you'll probably be able to find 2 that aren't fractions that will work, that you don't have to get to the fractions. And most of the time, I probably wouldn't try 24 or 12 or even 8. I would start with the smaller numbers. Now, 1 we can check. It's not going to work though on this one. I should have made up one where 1 worked. You definitely have. I see 1 right now already in your homework that 1 is a 0, maybe 2, definitely 1. But anyway, so we add 9 minus 9 minus 58 plus 4 plus 24. It's not going to be a 0. So we want to start trying numbers to do B that are not 1 and not fractions, unless you just want to do fractions. So let me know if you guys figure one out. Did anybody get one that works? 3. 3 definitely works. Now, if you got a different one, you don't have to start over. There's 2 that work. Okay. Now, if this gave us a a cubic function that would factor by grouping, you can do it that way. You would write 9x cubed plus 18x squared minus 4x minus 8. And if it actually will factor by grouping, you can do that. I want to do it this way just in case you get a situation where it doesn't, so you can see what to do. So you're going to bring down not the remainder. So if you get a remainder of 0, you can do a shorter version of the polynomial, it still has the same zeros, just not 3 anymore. Did anyone get another number that worked? It's -2. I think, yeah. Okay, so then this gives us 9x squared minus 4 equals 0. And we know how to solve every single quadratic equation in the world. We can, this one will factor if you wanted to factor it. I feel like most people don't, but you could. Like if you wanted to factor it, it would be the difference of squares. Right. I feel like most people, though, just solve it for x by adding 4, dividing by 9, and taking the square root. But either way, you're going to get the same zeros, positive and negative 2/3. Which they're in the list. We have positive and negative 2/3 in the list because they're possible zeros. They end up to be actual zeros. All right, for your factors, for positive and negative 2/3, you can use these right here. They definitely work. Or if you wanted to, you could do x minus 2/3 and x plus 2/3. Up to you. 100% up to you. And then we found those by guessing, x minus 3 and x plus 2. I don't have a preference. I really need you, if this is a multiple choice, to know that they're both right. Both of those choices. All right. What questions do you guys have on finding zeros? I feel like we've been talking about polynomials for a really long time. All right, so your assignment is to do these 5 problems, all those things that we just did, ABC. Don't forget to check 1. So if you add these coefficients and that constant and you get 0, 1 is a 0. So then you just do your synthetic division with 1.